Hello and welcome. My name is Gareth Emslie. I'm a product manager at Dynatrace. I'm pleased to be here today to talk to you about how you can go from zero to DevSecOps hero by extending Microsoft Sentinel. So the information presented in my session today is based on my personal experience and my own opinions, not those of my employer. Mention of any specific product or service does not imply endorsement. I also don't claim to be an expert in all, or in fact any, of the areas we'll talk about today. An article published by The Economist in 2017 highlighted how data had surpassed oil as the driving force of the global economy. Just as oil fueled industrial growth, data now powers the digital era, enabling companies like Google, Amazon, and Facebook to dominate the market. Of course, the value of data has not gone unnoticed by bad actors. According to the 2023 Data Breach Report published by Identity Theft Resource Center, the number of data breaches stayed fairly constant over 2021 and 2022 at 1,800 public incidents. But in 2023, data breaches reached an all-time high, with 3,205 publicly reported incidents affecting over 353 million individuals, marking a staggering 78% increase from the previous year. This surge highlights how data has become a prime target for actors, as in organizations and individuals increasingly rely on digital platforms. According to the Data Breach Report, social engineering led the pack, accounting for 18.5% of breaches, followed by ransomware at 10.4%, malware at 4.9%, and zero-day attacks at 4.6%. What is unfortunately not surprising is that 74% of all breaches involved a human element. This continues to underscore the importance of addressing human vulnerabilities such as phishing, pretexting, and other manipulative tactics. Ransomware continues to be a lucrative strategy for cybercriminals, as organizations are often forced to pay to regain access to their data. Unfortunately, today's operations teams are not only challenged by attackers, they are also challenged by complexity. The digital landscape is growing more intricate every day. Organizations rely on multiple tools and systems across on-premise, cloud, and hybrid environments. This complexity makes it difficult for operation teams to manage oversight, leading to gaps in security. Of course, the sheer volume of data generated by modern IT systems is also staggering, with data flowing in from endpoints, networks, cloud services, and IoT devices. Operation teams are inundated with alerts, many of which are false positives. This alert fatigue makes it harder to detect real threats in real time. Managing security operations is also expensive. The need for advanced tools, skilled personnel, and continuous training drives up costs. Moreover, the financial impact of breaches and compliance requirements adds to the burden, making it challenging for organizations to allocate resources effectively. Correlating events across multiple sources in a world of fragmented data is a monumental task. Without proper correlation, critical insights are missed, and teams struggle to connect the dots between seemingly unrelated events. According to the Threat Stack SecOps report, 52% of companies admitted to sacrificing cybersecurity measures to meet business deadlines or achieve faster product releases. This statistic underscores a common tension in the DevOps workflow, where the pressure to deliver quickly often leads to cutting corners on security. Organizations must recognize that speed and security are not mutually exclusive. By embedding security practices into the DevOps pipeline, transforming it into the DevSecOps pipeline, teams can achieve both agility and robust protection. This, of course, requires fostering a culture of collaboration between development, operations, and security teams, alongside leveraging automation and advanced tools to streamline processes without compromising safety. The ultimate goal is to deliver innovation at speed while safeguarding against evolving cyber threats. Microsoft Sentinel empowers SOC teams by combining advanced threat hunting, security orchestration, automation and response, so SOAR capabilities, and integration with external systems to streamline the incident lifecycle and remediation process. Sentinel enables SOC teams to define complex analytics rules to detect threats. These rules can trigger automated incident creation, ensuring that threats are flagged and addressed immediately, reducing the time to detection and response. Sentinel SOAR capabilities leverage playbooks and automation rules to manage incidents centrally. These tools allow teams to standardize incident handling, automate repetitive tasks and orchestrate responses across multiple tools. Automation reduces the manual effort required for incident response, enabling faster resolution and allowing analysts to focus on more critical tasks. The MITRE ATT&CK framework is a globally recognized knowledge base that maps adversary behavior into structured tactics. So, what attackers aim to achieve, and techniques, how they want to achieve it. Microsoft Sentinel integrates this framework to help SOC teams identify and classify threats within their environments. By aligning hunting queries and analytics rules to MITRE tactics, Sentinel provides a clear and standardized view of potential attack paths. Sentinel's hunting queries are grouped by MITRE attack tactics such as initial access, privilege escalation, and data exfiltration. This allows SOC teams to focus their investigations on specific stages of an attack, making it easier to identify and mitigate threats. Sentinel includes pre-built queries designed to uncover potential threats. These queries are mapped to specific tactics and techniques, guiding analysts towards the right data and helping them uncover issues in the environment. Analysts can sort and filter queries by data source, tactics, or techniques. This flexibility allows teams to prioritize high-risk areas and focus on the most relevant alerts. Microsoft Sentinel's Content Hub is a game changer for SOC teams, providing them with the tools and integrations they need to protect their organizations in an increasingly complex threat landscape. By leveraging this centralized marketplace, operations teams can enhance their security posture while reducing the time and effort spent on configuration and management. Microsoft partners can publish their own connectors and solutions directly to the Content Hub, making it easier for their customers to adopt and deploy these integrations. This open ecosystem fosters collaboration and innovation, allowing organizations to benefit from a constantly expanding library of tools. So, does Sentinel have the vendor integration which you're looking for in the Content Hub? If not, we can create it in a couple of simple steps. For example, take Dynatrace Runtime Application Protection, which is a security solution that detects and mitigates sophisticated threats like SQL injection, JNDI injection, command injection, SSRF attacks in real time. It provides code-level visibility through its one-agent technology and enables automatic blocking of detected attacks. In this presentation, we're looking for a vendor which exposes REST APIs, which can be leveraged to bring the vendor's insights into Sentinel. In this case, Dynatrace provides APIs to query all attacks as well as to get the details of a specific attack. So Microsoft Sentinel provides a couple of options for building connectors to query these REST APIs and bring the relevant insights into Sentinel. First option is logic apps. So these can be acquired through the Content Hub. They have fairly intermediate REST API support, right? When in a what is what you get style interface. But unfortunately, they require additional Azure resources deployed to the customer environment. Another option is Azure Functions. These also can be acquired through the Content Hub. They have far superior REST API support, right, in code, but unfortunately, they also require additional Azure resources deployed in the customer environment. The final option is Codeless Connector Framework. These can also be acquired through the Content Hub. They have fairly limited REST API support, but no additional Azure resources are required in the environment, in the customer's environment. So CCF is recommended as Microsoft hosts and runs these connectors, and the end user does not have to deploy resources in their Azure environment. Our data connector will ingest the raw JSON responses from our REST API. Now, when this happens, the table schema, at least with the HTTP data collector API previously, the table schema was automatically defined on ingest. Fields were suffixed with their type, for example, _s for string, and tables with _cl for custom tables. Today, Microsoft Sentinel leverages data transformation and the advanced security information model for normalizing and enriching ingested data. This enables efficient threat detection and investigation. So now, at ingest time, data collection rules are applied during ingestion to normalize and transform raw telemetry, which we saw in the previous slide, into standardized formats. This process ensures that data is ready for immediate use, reducing the overhead of processing large datasets during analysis. KQL transformations are applied at this stage to filter, enrich, and/or structure data before it is stored in a Log Analytics workspace. At query time, the asym parser comes into play. It uses KQL functions to transform and normalize data dynamically at runtime. This allows SOC teams to analyze data from multiple sources using a consistent schema without needing to manage the underlying complexity. Another option is leveraging a custom parser, which is a source-specific parser, which uses KQL functions to do something very similar. In the slide, we can see an example of data which has been ingested via data collection rules. We can see that the custom table still has a suffix of underscore CL, right? We have the same data type support, so things like string, int, and long. We were able to transform the ingested data by adding a time generated field, which is required. And it's important to note that billing is based on the volume of data analyzed, and of course the storage of that data. So as we saw, data collection rules allow us to define the ingestion pipeline upfront. We can define the table schema. We can apply transformations to the ingested data. For example, filtering, adding fields, removing fields, and we can also send data to multiple destinations. Once you ingested your data, you can use custom query language to perform advanced analytics across the entire dataset, as well as produce visualizations of these results. In the next slide, we'll see how you can also leverage KQL for runtime analytics. We can reduce human error and increase accuracy by automating threat detection. In Sentinel, we can do this by using analytics rules. We can schedule KQL queries to be evaluated continuously and trigger creation of alerts. We can also automatically create incidents to be triaged and remediated by operations teams. Sentinel connects raw telemetry from various sources, such as logs, network activity, and user authentication events. We could, for example, query failed login attempts across systems to identify potential brute force attacks. We would create a scheduled analytics rule using our KQL query. In this example, a rule is configured to detect 10 failed login attempts within a 5-minute window. These rules are run at regular intervals, analyzing raw data from a defined lookback period. If the query results exceed a defined threshold, the rule generates an alert. When the rule detects suspicious activity, such as a repeated failed login from the same IP address, alert is created. These alerts can be aggregated into an incident that SOC teams can investigate further. There are some additional rule types which are available. The near real-time rules, these provide a faster detection by running queries every minute. These are ideal for time-sensitive threats. Anomaly rules, these use advanced machine learning to identify unusual patterns in the data. And Microsoft security rules. These automatically create incidents in Sentinel based on alerts from other Microsoft security solutions, such as Microsoft Defender. So Sentinel enables organizations to monitor the health of their data ingestion processes using tools like the Data Collection Health Monitoring Workbook and the Sentinel Health Data Table. The Health Monitoring Workbook is basically an out-of-box workbook, provides a comprehensive view of the data ingestion process. It allows teams to monitor ingestion size, latency, and the number of logs per source. The workbook includes 3 key tabs: the Overview tab, which displays overall ingestion status; the Data Collection Anomalies tab highlights irregularities or interruptions in data ingestion; and the Agents Information tab monitors the health and connectivity of log analytics agents, ensuring data is being collected as expected. The Sentinel Health Data Table provides granular insights into the status of the data connectors and ingestion health. It tracks success and failure events for each connector, enabling teams to identify and resolve issues quickly. The table supports querying for specific health drifts, such as connectors transitioning from success to failure, or identifying the latest failure events. Okay, let's take a look at how you would build your first connector. As I mentioned previously in the session, Microsoft maintains a GitHub repository where all the Sentinel solutions or source code is available. So you can see here all the instructions basically for contributing to this repo are here. If we look, there's a solutions folder. This is where we will primarily be working today in this demo. I'll show you exactly what steps you need to execute to create a new solution which will be available in Sentinel. Okay, so let's open up this repository locally. All right, if we go into the solutions folder, we go and look for an existing solution which I created, which is Dynatrace. So we have to follow the convention of basically the vendor name in the solution folder, and then within that vendors folder, analytics rules, data connectors package. This is produced when you compile your solution, parsers, playbooks, and workbooks. Okay. So an important thing that you need to create is the metadata file. So the metadata file describes all the artifacts which are part of your solution. It also describes how your solution is supported, and you're able to provide a description, logo, etc. for your solution. Okay. What we saw in the presentation is that the very first thing, how you get data into Sentinel is via data connectors. Or one of the ways is via data connectors. And in this demo, we're going to look at how you would create a data collection rule-based data connector. Okay, well, there are a number of files that we need to create, right? We can see here, we need to define essentially the data collection rule itself, right? And so this, basically we need to define the schema for the table, right? When we're ingesting this data. We need to define the destinations where we want to actually send the incoming telemetry. And then another very important step is we need to define the transformation query which we'll use. So the custom query which we use to transform the data as it's ingested. Okay. So another very important file which we need to create is we need to actually set up the polling configuration, right? So we're going to build a codeless CCF connector, right? So we don't want the customer to have to manage any sort of infrastructure in Azure. We want Microsoft to basically manage the polling and the running of the connector within their infrastructure. Okay. So of course we need to give it a useful name. And basically in this file, what you can do is we can define things like what specific parameters are required, right, when polling the REST endpoint. So of course we need to know the address of the endpoint, and this can be parameterized, right? So we will see in the UI how we actually provide the Dynatrace environment URL. But basically we concatenate that with the actual REST endpoint, which we're going to connect to. We can define the HTTP method. We can define also how retries happen. We can define time format. So this is for basically for the query string, right? We ask the API to return a text, in this case, between a start time and an end time. We can also define some HTTP headers and any additional query parameters which are needed by the REST API. In the response, we can actually tell the connector where to look for the data that's important to us, right, in the JSON. In this case, we're looking at the attacks array. Finally, we can actually specify which DCR to use. And so this was the file that we saw previously. We referenced this from the polling config. And of course, very important is how paging happens, right? In this case, we're looking to use next page token paging type. And we're looking at basically, we specify where the page token is in the response. So in this case, it's called next page key. And we can also, it's redundant in this case, but we can also rename the next page query string parameter. Okay. So another file we need to define is the table file, so workspace table. So in this case, we define the schema for this table, which is used in the DCR. As I mentioned, time generator is a required field. Here we define what the schema will look like after transformation. So you can see there's no suffixes on field names, which indicate types on an _s. In this case, we also define then the type of each of those fields, right, in the table. Now, once we have those three other files, we can now tie them together with the definition file. So here, what we need to do is we can define the connector UI. I can show you in a little bit what that looks like. But basically, we can define what the publisher name, description, all those things that will need to be displayed in the Azure portal to the end user. We can also define some example queries, as well as graph queries, for example, for how much data has been received over time and which table to look at. We can, this availability section, basically we use that to mark a connector as preview. In this case, I'm using it in the demo. And you would set this to false, right, when a connector will be generally available. We can define what permissions are required, right, on the workspace itself. So we need to, of course, write permissions are required on the workspace to ingest data. And then we can define some custom elements which are displayed, right? So in this case, I specify the requirements on the vendor side. So in this case, we need a Dynatrace tenant with a specific feature activated. And of course, we need an access token, which allows us to read attacks from the REST endpoint. In this case, an access token is used for authentication, but obviously the connector framework supports multiple types of authentication. We also need to define instructions for the end user, right? In this case, the customer has to supply us with a URL, right, or their tenant, which they want, or their environment that they want to connect to. And then, as I mentioned before, an access token is required. So this is something that the end user has to provide us as well. Finally, we set up a connect toggle button, which you will see later in the UI. Okay, so that's the data connector itself. I'll show you in a little bit how we actually, what that looks like, right, in the Azure portal. So some other interesting things to show you, I think, in this demo are analytics rules. So we can define analytics rules for our solution as well. So this essentially creates a analytics rule template, right, in your Sentinel workspace, which you can then create instances of that. You can create an instance of that and run it to raise alerts, right, as I mentioned in the presentation. So in this case, what we're doing is it's defined in YAML in my demo, but we give it a name, description, status, which connector it's actually dependent on, as well as the query frequency, the query period, and basically tactics, so the MITRE framework tactics and techniques, how we group the alerts, and then very important, of course, is the query that we want to run. In this case, we're looking for all attacks which are not allowed listed. Okay. And we're giving it a custom name. So based on basically a format. So we're looking to call it Dynatrace attack with this current state, display ID, which is from Dynatrace, and then the display name from the Dynatrace attack. Okay. We're also configuring that we should create incidents based on these alerts. And we group the alerts over the last 7 days. And we have to match, so we're doing entity mapping here. We need to match all entities within the alert for that to be grouped. Okay. I won't go into a lot of detail, but we also have some parsers included in the solution, as well as playbooks, which essentially are automation, allow you to automate processes based on like alerts or incidents. And we can also include workbooks in our solution. So workbooks like dashboards, essentially. Okay, so what does that look like in the Azure portal? So we can come to Content Hub. In this case, we can see Dynatrace has a solution published to Content Hub. We can see all the content which is included in the solution, right? So things like analytics rule, templates, data connectors, workbooks, parsers. That's all available in this solution. So in this case, I've already installed the connector, but basically if it was not installed, you'd have the option to install it here. Okay, so once it's installed, you will see that there'll be a number of data connectors available to you. So for the purposes of our demo, we're looking at attacks. So in this case, I've created a V2, which is a preview version of the connector, which leverages data collection rules. And the V1 was basically the prior version, right, which used prior technology from CCF. Okay, so if we open that V2 connector page, we'll see it's already connected, right? So right now, attacks are being ingested into Sentinel. We can see over time how many attacks or events have been received. We can see here what we defined in the JSON files, right? In the UI config, we can see the customer or the end user and needs a Dynatrace tenant with specific feature enabled. We can see that an access token is required, and we can provide documentation to the end user on how to set those things up. We also need to get, of course, the URL of the environment that the end user wants to monitor, and access token in this case to authenticate those REST calls. So the other thing which we can do is we can create So we can come in and look at the rule templates which were provided. So in this case, there are a number of different templates provided out of the box by the solution. In our case, we're interested in attack detection. So here we can say, okay, create a new rule based on this template. By default, the arguments or the parameters that you see, the inputs, are set to default values, right? Which we defined in the solution in the YAML that you saw earlier. We can change this if we like. We can alter the severity. We can alter the MITRE characteristics. We can also come through and say, okay, we wish to alter the KQL query, which is run, which is scheduled. We can define different entity mapping. In this case, we're mapping IPs and host names. We can also change the query scheduling. So currently it's run every 1 day, and we look back 1 day. We can change the threshold, right, where an alert is generated. In our case, if there's more than 0 items in a return, then we want to generate an alert. In our case, we also trigger an alert for each event, but you could also group these into a single alert. Okay. We can configure incident creation. So in this case, we are by default, and then we're also configuring alert grouping. So we're grouping alerts from the last 7 days into a single incident if the entities match. It's possible also to trigger automation rules or playbooks, right, using analytics rule. In this case, we'll leave it like it is. Click Save. Okay. So now what we'll see is that alerts will start to be generated based on this new rule that we've set up. Okay, we've seen what our solution looks like in the Azure portal. Now, something I haven't shown you yet is how you actually package your solution, the content for your solution into a package, which you can then submit to the Microsoft Partner Center and publish, right, publicly. So let's take a look at how we do that. Okay, so what we need is basically to copy the path to the data folder in your solution. We go into the tools folder within the repository, right? So if we look at, I'm here currently at that path within the repo. I run the PowerShell script, create solution v3. I paste in my solution data folder path, right? This goes through a number of steps, preparing basically the new package, which we'll be able to publish. Okay, once that's completed, it produces a number of output files, number of outputs, and also a package file, right? So if we go and look at that, if we go into our package folder, right, you'll see there's a new version, a zip file, so 3.0.2, which we would use to publish our solution publicly. But what is also interesting is that we have the UI definition file, as well as the ARM template, so the Azure Resource Manager template, which we could potentially use. So you can actually go into the Azure portal, and you can say deploy custom template, and we can say build our own template. We can load the file. So in this case, let's get the path to that file. Okay, we click save. We then can provide, in this case, we can create a new resource group. We provide all the parameters, right? In this case, the analytics workspace, resource group, the location for the workspace, the name of the workbook that we want to create, resource group name. You can leave these values as they are. They'll take whatever is set at the deployment level. And once you've entered in all these parameters, you click next, and this will essentially deploy the side load the solution right into your subscription. So you won't have to publish it by a partner center, for example. You can actually deploy it this way to test your solution and the content that you're deploying with your solution. This is what I did for this demo. Our goal as an enterprise should be to limit threat impact by triggering immediate response on threat detection. Manual triage and remediation is often slow, prone to human error, and resource intensive. Security teams face challenges such as delayed responses to threats, high operational costs due to 24/7 staffing needs, fatigue and burnout from handling repetitive tasks and high alert volume. With automated triage and remediation, Sentinel replaces manual workflows with automated triage and remediation processes, ensuring threats are addressed in real time. Automation rules and playbooks are used to evaluate alerts continuously, trigger immediate responses, and reduce the cost of operations. Thank you so much for watching my session today. I hope to see you again really soon.